Well, g'day, Max here again. Welcome back to the shop. So today's video we're going to be concentrating on my smaller of the set of angle plates that I fabricated up quite some time ago. So what our aim is to at first get all of the rough machining operations carried out, and then we'll do the finishing. Well, we'll have a measure up then and see how it goes, and if we can get things within close enough tolerance, we will start with the finishing cuts on it. So this could actually drift into a two-part series. So we actually need to make up some T-nuts, so I'm in the middle of doing that at the moment, and I'll just put a couple of clips in on that process and keep that very brief. So, and we finally got the top on our little bench here. So my preference is always to have a bench behind me. That's just what I'm used to, and that's what I like. So this is a piece of 2-inch thick Jarrah, which is West Australian hardwood. I think it's classified as a softwood, but it's quite hard wood. So it's yeah. All right, let's head over to the shaper and we'll show you what we have to do with our angle plates. Yeah, so this, when it's finished machined, we're going to cut it in half and get two reasonably matched sets of angle plates. So I prefabricated this up out of 350 grade plate quite some time ago, and it's been in a very large fire for a long time, and just to help try and stress relieve it a little bit. It would have been nice to have had them properly done in an oven, but we can't afford that luxury. So these are 1-inch 25mm plate, and we're looking at just under 12 inches long, 300mm by 4.5-inch 115mm by 5.5-inch or 140mm. So and we have some larger ones that I've done as well, but I'm just going to do the smaller one first. So what we want to do is get the whole outside, the whole thing machined, rough machined, and then we want to play around with some finishing cuts so we get that nice shaper pattern in the machining. We'll see how we go with that, but I think the feed on this machine may be not quite coarse enough, but we'll see what we can do. So first up, before we do that, let's get our T-nuts finished and let's rock and roll onto this. So we've finished profiling our piece of stock to make our T-slot nuts out of. So before we drill and tap the holes and cut them off, I just want to put in a little relief groove right in this corner here on both sides, and that'll just give a bit of relief clearance for the very corners here of our T-slots. Okay, that's just given us a bit of a corner relief there. I've just marked it, highlighted it with the Sharpie, otherwise it'd be pretty hard to pick up. But it's just enough so the corners of the T-slots don't interfere with the slight radius on the, well, what would have been a slight radius on the corner of the T-slot nuts. And that's something that's not done on most of your generic T-slot nuts that you pick up. Your average average quality to cheap quality ones, it's not done. So yeah, here's an average T-slot nut, and you can feel it with when you put a ruler in there. You can feel that radius right in the corner there, and it does over long term have a detrimental effect, especially on like a Bridgeport milling machine table. If you get the underside of the T-slots peened up too much, it'll bow your table. So this is my reversible tapping head. It's a Piper brand, made in Australia, very old, and it's in pristine condition. So the chuck there grips the tap. Does a magic job. It has a 1/2 inch capacity. And yeah, brilliant bit of kit. So we'll take them over to the saw and chop them up. We'll get 6 T-slot nuts. Right, 6 M12 T-slot nuts completed. So let's get to our job in hand, our angle plate. Oh, and the reason for making these, apart from I didn't have bugger all of them, is we'll probably need them to clamp down our angle plate. We'll start machining it probably in the vise, and then after the first operation we'll be using these to clamp it down to the table. The plate's got a bit of a hollow in the middle of it, so we're pretty close on either end, and it dips down in the middle there. But it's close enough. Well, there was a lot of interrupted cuts going on there getting through that weld. Probably got 3mm, got over 3mm, 1/8 of an inch to go. You see the change in finish, so it has damaged that insert, so we'll just rotate it round. But this insert's not it's just a generic insert. There's nothing flash about it. It's just a common grade insert. So rotate it round. We'll go again. Yeah, I think the high-speed steel would have struggled getting through that. Right, let's take another cut. Well, that's through the worst of it, so I think we'll swap over to a bit of high-speed steel. Interesting, there's this little line running down here. So that's as far as it got before the insert chipped. Then it chipped again, and then the finish came back more on a par with what we started with. So I'll get some high-speed steel in. Right, well that's not too bad. I think we will just take one very light clean-up pass along there, and then we'll look at trimming up the sides and getting as much done as what we can while we're still in the setup. Yeah, so if I can get as much as I can down here, possibly down here as well, it gives us something else to indicate off to set up on as well. So yeah, I'll just give this a quick light. I'll change the tool. I might see what other tools I've got. The rapid feed and just a very light cut. Okay, we've got our new tool in, so we'll come across that it's a fairly rapid feed, and we'll just do a very light cut, maybe probably 0.2 of a millimetre, maybe 0.1 of a millimetre. We'll just see how it goes. Okay, we're just touching there. Come down about 0.2. Well, it's better than the badger's arse effect from the previous cut, the roughing cut. There's still a bit of a badger's arse syndrome going on here. It's got these weird lines running through. I think that's something caused by vibration or something from the machine. I think I'll just take a spring cut. That was actually went a little bit deeper than what I had fully intended to there. So I'm just going to wind it back and take a spring cut. Well, that was a spring pass. Well, for all intensive purposes, I like of a preliminary clean-up cut. It's not too bad. There is a lot of room for improvement, but for now it'll be perfectly adequate. The tool would get a better finish if I had a bit more side and back rake on this tool, but I don't want to do that because this serves me a better purpose as a form tool for the lathe. So we'll come up with something else then for a really need like a dedicated shear tool or something like that for a finishing cut. So that's something we'll have to look at, but for now that's adequate. So our next setup then will be to trim up the sides as best we can. So this is the weird pattern chatter formation that I'm getting right across the face of the part. It's only very fine, you can see it in the light, but what I just put it down to is chatter. That just keeps repeating, and from when the tool first starts the initial cut coming across, and I think it's all due to a bit of play in the machine, which we'll be taking up and taking care of when we do a major works, major repairs to this machine. Like the ram will be coming off and the table's coming off. Everything's got to come off for inspection, but we're just getting this job out first. So anyway, let's get back and we'll cut our edges. So even though this machine has automatic clapper lift, when we're cutting a vertical face, we still have to angle the clapper box all the way over. So as the tool comes up, it swings away from the work. Let me give you a closer shot of that. So if this parallel strip represents the edge of the work, on the return stroke, when the tool is lifted, this will come up, and now we have adequate clearance under there now, so the tool doesn't drag on the face of the work. And something that is rather important too, this is our reference face here for everything that we're going to do. So we need to make sure that our tool slide that we're using to cut the vertical faces is perpendicular to this. So we just check it with an indicator, and I just use a gudgeon pin out of a large engine. These are pretty accurate. So we've got no movement on our indicator there, so we're in a good position. Right, this is as far as we're going to go on this side. You can see these diagonal lines. That's those chatter marks. It's a similar thing to what we were getting on top earlier. So, but now that's fine, as we're still in our roughing stages. So we'll get the tool flipped over and we'll do the other side. And we better get this thing deburred. Right, now that actually is I don't know how much filing you guys do, but John from John's Workshop did a video on filing the other day, and John and myself were taught at the beginning of our apprenticeships how to use a file. You don't do this malarkey backwards and forwards, but you don't. You only run a file in one direction and lift. That way you can see what you're doing. Right, let's get our tool set up and do the other side. So the tool that we were using just then is this one here. It is a brazed carbide variety tool, and I did a quick grind on it this morning. Rough as a badger's ass, but it held up very well. So this actually needs to go into the tool and cutter grinder, and we'll do a proper grind on it. So the tool that we're going to use for the other side is this one here. This is a very old tool that came with the machine. It's a bit weird, this one. It's standard stock for the shank of the tool, and you might be able to see a difference in material there. So the end of it is different material than the stock. So I don't really know what this is, whether it's some form of high carbon steel or stellite or exactly what it is. It's a lot more corrosion resistant than the standard stock of the steel. As before I played around with it, yeah, this wasn't rusty compared to the body of the steel, so it's unknown variety, but we'll give it a go going down the side there. See how it goes. Okay, this tool stood up quite reasonable. So, this a bit of a deburr. Okay, so now we're set up very well for our second operation. So this gives us a really good parallel edge and a flat surface now to grip the part in the vise. So what I was talking about before with the stresses clamping like this, we don't know if this had well, we've seen a bit of a bow from our first cuts when we were just contacting here and here. We don't know if that goes all the way down the depth of this. If that's the case, I've got this grip pretty tight in the vise. So the vise will influence any bow, and when we release the vise, that bow will come back. So that's why we're not interested in going down any further than that. There will be no bow in this area here because we have the solid section behind it. So this will give us something true to grip on for our second operation. So this can come out of the vise now. Okay, well, we're well into our roughing stages of our angle plates, this being the smaller one of the three. I'll put a link in the description for part one. Now, part one of this series I did a long time ago. We're back in the old little shop that I had at home, and that covers machining the plates for doing the weld prep and the welding of the plates as well. So what we're going to do in the following video, we're going to finish our roughing operations, and then we'll move into the finishing cuts and the final squaring and tolerancing of the angle plates. So anyway, cheers, thanks for watching, and see you next time. Have a good new year.